Hi, it's Lil Math. Welcome back. Last time we talked about finding area using vectors and determinants of 2D shapes, and today we'll be talking about how to do that in 3D. Now, these two lessons are very related, and it's helpful because if you know how to do it in 2D, it's fairly easy to do it to find area or to find the determinants for 3D for volume. So yeah. So basically, the only difference is last time we were given vectors A and B. This time we also have vector C. And so last time I talked about how if you're doing vectors just A and B, then you do the determinant of A, B, and then you make a matrice that's, A1, A2, B1, B2, and then to find the determinant, you're going to do A1, B2 minus A2, B1, right? Pretty easy. The main difference is that this time, this is for 2D, right? For 3D, so this is for area, for volume, the main difference is that you're just doing the determinant of A, B, C, and so instead of getting an ABC where rather than having like this is A1, A2, right? It's in 2 dimensions. This is going to be A1, A2, A3, so on and so forth, like B1, B2, B3, C1, C2, C3. And so the main difference is instead of getting this is a 2x2 matrix, you're going to get a 3x3 matrix. So your matrix is going to look like A1, A2, A3, B1, B2, B3, C1, C2, C3. This is your matrix. And so you may be thinking, okay, great. So if it's 3x3 instead of 2x2, how do you do this part, right? Because so writing out the matrix is basically the same except you have an extra column, and the multiplication for finding the determinant is a little bit different, although not that much. So just like with before, you're going to start with that upper leftmost corner, right? That is your first thing that you're multiplying. Except this time, the thing you're going to multiply it by is the determinant of this little 4x4, or not 4x4, sorry, 2x2. 4 numbers, 2x2. And one way to remember this is you're going to multiply it by, so I'll write that out to show you. So you're going to do B2, C3 minus B3, C2. And so one way to remember that is you're going to multiply this by, you get rid of everything in this row, and you get, or column, and you get rid of everything in this row. So you get rid of the row in the column that the number is a part of. And then you're going to take the determinant. We already know how to take a 2x2 determinant of the remaining 4 numbers, right? So you're going to do upper leftmost times bottom right, upper right times bottom left, and then there's a subtraction in between. But we're not done yet. That's only one part of it. So next, so as with like in a 2x2, right, you just move along the upper row, right? You go from A1 to A2, and you subtract the second one. So this is the same, right? We're doing minus A2 times some value, except this time the value, you find it by, again, get rid of the row that A2 is in, get rid of the column that it's in, and then you look at these four, these two, and these two, the four remaining numbers that you have, and you take a determinant of those numbers. And again, you take it along this diagonal minus this one. So that's going to end up as B1, C3 minus B3, C1. Oh, sorry. But again, we're not done yet, right? Last time we were done because we only had 2 in the top row. But in this one, we have a third one. And the plus and minuses alternate. So this was a plus A1, whatever this value was, right? And this is a minus A2. So we're going to have then a plus A3. And hopefully you can figure this out by now, but how we get this value is we get rid of this row, get rid of this column, take the determinant of this 2 by 2 matrix. So we're going to do B1 times C2 minus B2 times C1. And this is it. That will give you the volume of, it's called a parallelepiped. I don't know how to pronounce it. I can spell it out. It's like parallelepiped. But it is, say you have too many matrices. You have vector A, vector B, and vector C. And you want to know what the area of this shape that they form is, right? You want to know what this is. Excuse my bad. I'm so bad at drawing shapes. Okay, you want to know what the area of this, that's what it's called. This is how you find it. You just take the determinant of those 3 vectors, and this is how you take it. And I know it looks kind of funky because there's a lot of A's and B's and C's, but really this is just going to look like, so let's say we have our A, our B, and our C vector, right? And I'm not going to work out all the math with this because it's just a lot of multiplying and adding and subtracting. But let's say we have, I'm going to do really easy numbers because I'm lazy. These are the values of our vectors, right? Oh. Right? These are the values of our vectors. Let's say, whatever. And basically this means your matrix is going to look like this, right? And then you just, like, that's your A1, that's your A2, that's your A3 in this configuration. But the point is, again, you just move along the top row, you get rid of whatever row and column the number you're looking at is in, and then you take the determinant of the remaining 2 by 2 matrices. And that'll give you this area, which is helpful because, volume, which is helpful because sometimes it can be hard to find the volume of things otherwise, and so this is just another helpful way of knowing how to find it. So yeah, hopefully that was helpful. Yeah.